Good morning, everyone. My name is Miyashita. Today, I'm going to present my topic on optimizing sustainability, exploring the paradigm of green computing with my teammates Tiaji Ghosh and Shreyasi Sasmal. So now these are my contents. Where the first point is what is the green computing, significance of green computing, aims and objectives, road to green computing, approaches and applications, cost of green computing, advantage and disadvantages, future of green computing, role of AI in green computing, and finally conclusion, reference and acknowledgement. Now, what is green computing? Green computing is the practice of implementing eco-friendly tactics into the use of electronic devices and their daily functions to correlate environmental actions necessary to cultivate greater sustainability. It is referred to as the design, manufacture, use and disposal of chips and other technological equipments, peripherals in such a way that limits the harmful impact on the environment, including reducing carbon emission and the energy consumed by manufacturers, data centers, and end users. Now I'm going to talk about the aims of green computing. The first point is minimize the use of hazardous computing products, which decreases the hazardous chemicals for which maximize the efficiency throughout the product's life cycle, makes the computing process more eco-friendly and increase energy efficiency. It has defined its role in helping to save the ecosystem. Green computing use machines and their assist in environmental conscious and eco-friendly manner. Purchase and use of green energy, save money due to reduce utility costs, design good algorithm for better computer efficiency. The quality of desktop resources needed for any particular computing function is affected by technique performance. According to Harvard's physicist research from 2009, the average Google search emits 0.7 grams of CO2. On the other hand, Google consisted with statistics claiming that an average search created 0.2 grams of carbon emission. Recycle of computer wasted products, final point. Now, some objectives of green computing. First one, minimizing energy consumption. Every device consists of sleep mode, which help us for energy consumption. Not only that, when the device is not in use, we can shut it down. Second point, purchasing green energy. Installing energy efficient windows and doors to reduce heat capacity and installing fans throughout the equipment's rack to reduce heat. Third point, reducing the paper and consumable use. We all know that paper plays an important role in contributing to the landfills, being approximately 25%. Over 2 million of trees are cut down for daily global use of paper. Trees are more important to the nature, so it is important to do what we can to save them. Fourth point, minimizing equipment disposal requirements. This is one of the most significant among all, as it decides the fate of used digital devices. Obsolete equipments with unwanted materials should be recycled. That means computers which are used not to be thrown, and repairing them, we can use them again. Last point, reducing travel requirements for employees and customers. Nowadays, travel is most important for everyone. Not only that, it is the primary source of greenhouse gases and thus the main contributor to the climate change. According to a study, carbon dioxide emissions from travel release carbon dioxide alone are expected to increase by 25% by 2030. Significance of green computing. First point is climate change. Second point, rising of carbon emissions, which causes global warming and energy crisis. Thus, green computing helps to create a sustainable business process, spreading awareness to build a better future. Third point, currently the ICT is responsible for up to 4% of global emission. My last point, currently the ICT is responsible for up to 4% of global emission, and data storage centers have risen to account up to 3% of global emissions. Furthermore, green computing is vital for every class of system. from large data centers to handheld systems and could reduce up to 7% of carbon emission. So these are some road to green computing 4 approaches. First point, green use, reducing the power usage of computer and its periphery systems and using them in an eco-friendly manner. Also adopting virtualization, reducing the needs of energy. Second point, green disposals. Recycle and rescuing existing equipments properly, disposing the waste, IT computing, materials, electronics, equipments, etc. Green design. Designing energy efficient as well as effective systems which have a minimal impact on the green environment. Green manufacturing. Manufacturing biodegradable materials, also manufacture long usable recyclable products and reducing wastage during manufactured products. So these are some results of green computing. Virtualization, recycle, cloud computing, energy savings, green disposals, maintenance and monitoring, green servers, and last but not the least, efficiency. Now I would like to call Shreyasi Sasmar to explain further.
Good morning everyone, myself Shreyasi Sasmar. Now let us discuss about the approaches to green computing. Green computing revolves around carbon-free computing. The steps to achieve carbon-free computing are consuming renewable energy instead of fossil fuels, virtualization of servers, making power source modification, and dynamic power management. So let us discuss the first point, how we could use renewable energy instead of fossil fuels. When we talk about renewable energy sources, the first well-known is solar energy. So solar energy leads to the idea of solar computing. Let us discuss how solar computing happens. So to convert solar energy into electrical energy, the main component are solar cells. These solar cells are made up of simple PN junction diodes, which are consist of semiconductors. So in this diagram, we can say a diagram of solar cell consists of PN junction diode. In the first, the PN junction diode is in forward biasing, and in the second, it is in reverse biasing. In forward biasing, the N side is connected to battery's negative terminal, and the P side is connected to battery positive terminal. Hence, the applied electric field surpasses the barrier potential at the junction, so the current flows through the circuit. But in case of reverse bias, the N side is connected to battery's positive terminal, and C side is connected to battery's negative terminal. So the applied electric field cannot surpasses the junction potential, the barrier potential at the PN junction, so no current flows through the circuit. So during using solar cells, the connection is always in forward biasing. Here is a representation of how the solar energy is optimized. Here we can see a rooftop solar panel to generate and use electricity. And here we can see how the solar cells in solar panels work as photovoltaic cells to convert sunlight directly into electricity. So let us discuss it further. When light reaches, here we can see, when light reaches the junction of the PN junction diode, it converts sufficient energy. It supplies sufficient energy to the junction to create a number of electron-hole pairs, and it increases the concentration of the electron-hole pairs in the PN junction diode. Thus leads to the solar cell acts as a battery, and if we connect it with a load, it will supply current through it. Here are two models where we can see how solar computing is optimized. In the first model, a battery is used, but in the second model, no batteries are used. So what does the battery do? The battery actually connects the current which is generated through the solar panels, which is actually DC current. DC current is stored in the battery, and then the DC current is supplied to the inverter, which converts the DC current to AC supply, and then we can use it for computing and any household purposes. But in the second model, it is directed, the solar cell, it is directly connected to the inverter, which converts the DC to the AC directly. No batteries are used there. Now, why we should use solar computing? First of all, we are using here sunlight, which does not actually creates any pollution. Secondly, the thermal collectors that are used in this process can actually achieve 400 degrees Celsius, which makes them ideal for powering any kind of computers and electronic devices. Solar computers don't produce any emissions, like we are not using carbon here, so no CO2 is produced, and these photovoltaic cells could charge the battery during the day, and we could use it even at the night. Here is a picture of real-life optimization of solar computing, where we can see solar panels which are connected to a laptop, a power manager which is supplying the required amount of power that is need or necessary to run the laptop. This is another example of using solar energy, where we can see a special kind of laptop that is specially designed for scientists and researchers. Here also solar panel is attached. It is attached with the laptop itself. This is complete power autonomy. It has GPS and wave access and communication systems as well. Now, second renewable energy is water. What about using water as energy source? So, this is called hydroelectric power usage. Hydroelectric power, as the term suggests, it is using water as energy resource. High-rise dams are built on rivers to impede this hydroelectric power. A generator and a turbine is connected to generate electricity by the use of water flow. The water has potential energy when it is at the top of the dam. Then, as it flows from the top, because of the gravitational force, the potential energy converts into the kinetic energy. And after that, when it reaches the turbine moves and converts it into mechanical energy, and the generator, AC or DC, converts it into electrical energy. So now this generated electricity can be used to run the computers. Virtual aggregate. This is very important. It is the answer to resolving the power consumption of data centers, because it allows several operating systems to sum on a lesser number of servers. So the basic concept of virtualization is pooling physical resources and managing them in a single unit. It is the process that provides the facility to create different views to the same server for different viewers. Virtualization leads to the way of cloud computing, cloud storage, which offers dynamic scale storage spaces. So basically, the virtualization implements multiple operating systems, and it allows a single computer to use multiple applications. Some example of virtualization is like VPN and routers. Maximizing efficiency with special algorithms, circuits, and hardware. So another way of achieving green computing is to design special algorithms that can run program considering minimum usage of memory storage or space consumption and time consumption. Specific circuits and hardware can also be designed to minimize equipment requirement. And here is a practical example. IBM has recently designed a chip which is 2 nanometer, and it consists of 50 billion transistors, and it can act up to 75% lower energy use than today's most advanced and most popular chips. Next is integration of programs. Heterogeneous structures like CPUs and GPUs can be used simultaneously or in a single computer to make it energy efficient. Like the CPU is used to do serial tasks, while the GPU is used for optimizing many parallel tasks simultaneously. So switching all the CPU-only servers running AI worldwide to GPU actually saves 10 trillion watt hours. Here you can see a diagrammatic representation of same work done by CPU and the GPU, whereas the GPU consumes very less energy and the CPU consumes more energy when it is. So GPU is always greater efficiency than the CPU. Then comes another example, AI MOS, Artificial Intelligence Multiprocessing Optimized System. It is a supercomputer. It is third most energy efficient computer. It is designed by IBM along with Empire State Development and NYCREAS. It is a supercomputer that is 24th most powerful and energy efficient for power saving, and also it has no almost negligible effect on the environment. Another path for green computing is lengthening the lifespan of computing devices. Why we need to do that? As we lengthen the lifespan of the devices, they don't need to be replaced frequently. So we can use them for a long period of time. And the next point is recycling. Nowadays, as gradually industries are increasing day by day, so the number of electronic hazards and electronic products are also increasing. So recycling plays an important role in green computing and saving our environment. So let us watch a video how this recycling process is done.
Electronics recycling can be challenging because discarded electronic products are complex devices manufactured from varying proportions of glass, metals, and plastic. These materials then need to be processed and separated into clean commodity streams that can be used to make new products. Resourceful production teams, trained technicians, and systematic and secure processing allow SIMS recycling solutions to provide our customers with closed-loop recycling services. This enables you to ensure environmentally responsible processing of your retired electronics, while minimizing the risks involved with handling sensitive digital data. Efficient separation of materials is the foundation of electronics recycling. Initial shredding of equipment facilitates sorting and separation of plastics from metals and internal circuitry. As a conveyor belt transports shredded material, a powerful overhead magnet separates iron and steel from the waste stream. This separated ferrous material is collected in gateways and prepared for sale as recycled steel. Further mechanical processing separates aluminum, copper, and circuit boards from the material stream, which now is mostly plastic. Visual inspection and sorting improves the quality of the extracted material. The separated streams of aluminum, copper, and circuit boards are collected in gateways and prepared for sale as recycled commodity materials. Using advanced separation technology, ABS plastic is separated from polystyrene plastic. This important separation step improves reuse potential in manufacturing next-generation products. Few recyclers invest in this innovative technology. The final step in the separation process locates and extracts any remaining metal remnants from the plastics to create as pure a stream as possible. This results in more efficient reuse of recycled materials. SIMS is uniquely positioned to meet the challenges of the electronics recycling industry. We are SIMS Recycling Solutions.
Now I would like to call Piali to proceed with further presentation. Good morning, everyone. Now I am going to continue with the difference between green computing versus traditional IT computing. Green computing, as you can see, is dedicated to developing energy-efficient technologies to work alongside the current state of climate change. Whereas traditional computing, IT systems have prioritized slimmer and speedier devices over the importance of sustainability in technology. In green computing, it does not focus on only work efficiency, but also strives to improve the energy efficiency or recyclable properties of various devices. Traditional IT computing may not allow for remote access to applications and data, limiting the ability to use it from anywhere. Green computing is more environmental friendly, whereas IT computing is less environment friendly. Now, the applications of green computing. First point, connected heating and lighting. The popularity of connected devices for heating and lighting, such as thermostats and LED technologies, it is increasing day by day. This helps to lower energy consumption by allowing you to control it by using various smartphone apps. Secondly, electric vehicles. Vehicles may now be powered by electricity rather than using gasoline, which causes pollution. Also, nowadays, with so many people seeking solutions to combat climate change, green computing is in demand. This explains why various manufacturers like Toyota, Tesla, and others offer a variety of alternatives. Thirdly, data centers. Electricity usage is a significant strain on data centers, which are also expensive. The world's top companies such as Google, Amazon, and Apple attempt to construct energy-efficient data centers. Lastly, recycling devices. Computers, mobile phones, and other devices are made with hazardous chemicals, precious metals, and other pollutants. Making them on a large scale is dangerous. So companies are beginning to recycle these wastes. Next, what can the users do to contribute to green computing? Firstly, power down the computer system and its peripherals during completion of its usage. Secondly, sleep mode the systems during extended periods of inactivity. Thirdly, use notebook computers and laptops instead of desktops, which emits large amount of heat. Fourthly, go for green packaging solutions. Fifth point, minimize the use of paper and use e-paper and also recycle the wastage papers. Sixth point, proper disposal of electronic wastage. Last but not the least, try refurbishing an existing device instead of going for a newer one. Moving on, the average cost of green computing. As you can see this chart, it consists of item, cost elements, cost per smartphone under current system ID, and comparing it with cost per smartphone under recycle and reuse system ID, and cost reduction ID and cost reduction ratio. Firstly, direct materials. As you can see, it is estimated to 2,74,350, and in the recycle and reuse system, it is 1,58,350. It is reduced, and the cost reduction ID is 1,16,000. The cost reduction ratio has amounted to 42%. And we can note that the total cost per smartphone under recycling and reuse have been reduced at a rate of 40%. Even though green computing costs more at the beginning, it can save money in the long run. Now, the advantages of green computing. Reduce energy consumption. Green computing basically emphasizes on energy-efficient technology and also to reduce the usage of fossil fuels, thus reducing the carbon emissions. Secondly, maintaining green environment. It encourages reuse of materials, resulting in less electronic waste and environmental pollution. Thirdly, cost-effective computing. It is cost-effective since it requires less energy and cooling, thus it saves money. Lastly, conservation of resources. Green computing also encompasses choosing sustainably sourced raw materials, reducing electronic waste, and promoting sustainability through the use of renewable sources. The disadvantages of green computing. Firstly, rapid change in technology. Green computing has yet to be explored and there is a significant gap in the knowledge across end users, professionals, and businesses. Secondly, initial implementation may be costly. Thirdly, requires care from user. Users may be unsure of what to do because of frequently technology adjustments. Fourthly, requires deep understanding of green computing concept. Finding out what is happening in their industry and committing to make changes might be impossible because of sheer amount of data. They must put extra effort into gathering and analyzing technologies which may be environmentally beneficial yet profitable for their organization. Future of green computing. First, cloud computing. It has received significant attention over years as a means of improving the utilization of data center resources. Data compressions. Intelligent compression system techniques can be used to compress a huge amount of data to get rid of redundant and duplicate data. Green IoT. IoT, that is Internet of Things, connects the world via advanced technologies which gives rise to loads of energy. Green IoT will make sure less consumption of energy and without reducing the performance of devices. Certifications received for green computing. There are several proactive organizations evaluating green technology and providing certificates to green technology. Secondly, vendors are selected based on their product quality, how eco-friendly they are, and the life of the product and recycling capabilities. Now, the role of AI in advancing green computing initiatives. Firstly, data center operations. AI-driven algorithms can be employed to monitor and analyze data center performance in real time, identifying inefficiencies and opportunities for energy savings. Secondly, deployment of energy-efficient hardware. Machine learning algorithms can be used to predict the performance of various hardware configurations, enabling designers to identify and select the most energy-efficient components and development of new materials. Management of e-waste. AI-powered robots can be used to sort and disassemble electronic waste more efficiently than human workers, thus saving time and reducing the environmental impact of electronic waste. Fourthly, efficient use of resources. AI-driven software can help organizations better manage their IT infrastructure, identifying underutilized servers and storage devices that can be consolidated or repurposed. This not only reduces energy consumption but also minimizes the usage of additional hardware. Development of smart grids. By analyzing vast amounts of data from sensors and other sources, AI algorithms can optimize the generation, distribution, and consumption of electricity, ensuring that renewable energy sources are used as efficiently as possible. Now some examples of green computing. For instance, Google has utilized AI to optimize the cooling systems in its data centers, resulting in a 40% reduction in energy usage for cooling and a 15% improvement in overall energy efficiency. Secondly, researchers at IBM have developed an AI-driven tool that can predict the performance of new materials for use in energy-efficient semiconductors. Now, with the conclusion, with the ever-growing needs of computers and IT infrastructure and other electronic devices, there is also a depletion in resources required to power those devices. However, computing devices developments can also provide solutions to businesses to adopt a greener way to ensure power savings and to protect the environment. IT industry is the crucial part of the sustainability program because of the amount of energy it consumes, number of e-wastes that is generated, and the number of hazardous materials that needs to be properly disposed or recycled. Although there are barriers that needs to be overcome in the long run, greener and sustainable future proactive action are required in the first step. AI is proving to be an invaluable ally in the pursuit of green computing. Now, these are the references and TX2.space, TechTarget, and IBM. Thank you, everyone.